Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a hexagonal pyramid having base edge 30 mm and axis height 80 mm. Now this hexagonal pyramid is resting on its base on the horizontal plane with one of its base edges parallel to the vertical plane. So here we can observe that the base edge EF happens to be parallel to the vertical plane over here. Now this hexagonal pyramid has been cut by two cutting planes. The first cutting plane happens to be an auxiliary inclined plane which is inclined at an angle of 30 degree to the horizontal plane. Now this auxiliary inclined plane passes through the axis of this hexagonal pyramid at a point 30 mm below the apex over here. So O dash point happens to be the apex. So 30 mm below the apex, this is the axis point. So this AIP, which is inclined at an angle of 30 degree, it is passing through this point of the axis, which happens to be 30 mm below the apex over here. And another circular sectional plane, it cuts this hexagonal pyramid with an arc having radius is equal to 30 mm shown over here. So from the right hand side corner of the base, so we'll take a radius of 30 mm. So since we know that once we draw this arc over here, so different points of intersection will be able to obtain between the circular cutting plane and different elements of this hexagonal pyramid over here. With this information, we are required to obtain the development of the lateral surface of the remaining portion of the truncated hexagonal pyramid over here. So now let us proceed with the evaluation of the top view and the front view projections corresponding to this hexagonal pyramid. When the observer is going to look at this hexagonal pyramid from the top, we are going to obtain hexagonal projections onto the horizontal plane over here. And the edge length, we know it is equal to 30 mm. So the 6 points of the base A, B, C, D, E and F, we have appropriately marked onto the top view projections corresponding to this hexagonal construction. Now let us evaluate the access point corresponding to this pyramid. So now we can see we'll be able to obtain the access points once we join the diagonals AD, BE and CF over here. So wherever these three diagonals they intersect with each other, we obtain the points O and O1. Point O happens to be the apex point corresponding to the axis, whereas point O1 happens to be the access point which is available at the base of this hexagonal pyramid. And another thing we should understand, as the observer will be looking at this hexagonal pyramid from the top, so all the 6 slant edges OA, OB, OC, OD, OE and OF, they are all visible to the observer. So having obtained the top view projections of this hexagonal pyramid, let us proceed with evaluation of the front view projections of this particular hexagonal pyramid over here. So we have obtained the projections from all the 8 points of the top view projections into the elevation projection view over here. So we have drawn the axis over here. We know that the axis height happens to be 80 mm. So once we mark this axis height into the elevation projection view, the apex point O dash will be located. And the moment we are able to locate apex point, let us now obtain the front view projections corresponding to the 6 points of the base and the axis point O1 onto the XY reference line. Now here we can see point A of the base has been projected as point A dash onto the XY reference line. Points B and F, they are going to coincide with each other and they will be projected as B dash and F dash onto the XY reference line. Similarly, points C and D, they will be coinciding with each other. They will be projected as C dash and E dash into the elevation projection view. And finally the base point D, it has been projected as point D dash onto the XY reference line, and the access point O1 has been projected as point O1 dash onto the XY reference line. So now we can join all these slant edges O dash A dash, O dash B dash, O dash C dash, O dash D dash, O dash E dash, and O dash F dash over here. Now here one thing we need to remember over here, the slant edge of this hexagonal pyramid OF, it is lying on the rear side of the solid. It's not visible to the observer. So the front view projections corresponding to the slant edge OF should have been drawn as a dotted line or the hidden line projections in the front view projections as O dash F dash over here. But these hidden line projections corresponding to O dash F dash, they have been overlapped or superimposed by the front view projections corresponding to the slant edge OB, which is going to coincide with the slant edge OF into the front view projections over here. So that is why the object line projections corresponding to the slant generator O dash B dash into the front view projections, they have overlapped with or superseded the dotted line projections corresponding to the slant edge O dash F dash into the front view projections over here. Similarly, the slant edge OE lies at the back side. So again, it's not visible to the observer. But this slant edge OE has been superimposed by the slant edge OC, which is lying onto the front side of the solid over here. So the hidden line projections corresponding to the slant edge O dash E dash, they have been superimposed by the object line projections corresponding to the slant edge O dash C dash into the front view projections over here. So now we have been able to obtain the elevation projection view and the plan projection view corresponding to this hexagonal pyramid over here. So now we know that an auxiliary inclined plane inclined at an angle of 30 degree, it cuts the hexagonal pyramid and it passes through the axis of this hexagonal pyramid at a point 30 millimeter below the apex over here. So we have marked a distance of 30 millimeter below the apex. So this point we have evaluated onto the axis over here. So through this point onto the axis, which is lying 30 millimeter below the apex, an auxiliary inclined plane inclined at an angle of 30 degree with respect to the horizontal plane, it passes through this hexagonal pyramid. So this portion of the hexagonal pyramid or the solid has been removed by this auxiliary inclined plane. So now let us evaluate the points of intersection which are obtained onto this cut section, which is obtained by virtue of intersection of the hexagonal pyramid by this auxiliary inclined plane inclined at an angle of 30 degree over here. So now the slant edge O dash A dash has been cut by this auxiliary inclined plane at the point 11 dash. So the first point of intersection has been obtained over here as point 11 dash. Now the next 2 points of intersection of this AIP with the slant generators O dash B dash and O dash F dash happen to be the points 12 dash and 16 dash over here. So point of intersection 12 dash, it happens to lie onto the slant generator O dash B dash, while the point of intersection 16 dash, it lies onto the slant generator O dash F dash over here. Then the next 2 points of intersection which are obtained on the cut section, they will be corresponding to the intersection of the cutting plane with the slant generators O dash C dash and O dash E dash over here. So 13 dash happens to be the point which is lying onto the slant generator O dash C dash, whereas 15 dash point of intersection is obtained by virtue of intersection of the cutting plane with the slant edge O dash E dash over here. Last point of intersection happens to be point 14 dash. So point 14 dash has been obtained onto the slant generator O dash D dash by virtue of intersection of the slant generator by virtue of intersection of the slant edge O dash D dash by this cutting plane over here. So now 6 points of intersection we have been able to obtain into the front view projections over here. Now let us obtain the orientation corresponding to the circular cutting plane. So there is another circular sectional cutting plane which cuts the pyramid with radius is equal to 30 millimeter, drawn from the right hand side corner point of this particular hexagonal pyramid over here. So once we take this radius is equal to 30 millimeter, so this point, that is D dash point, will be our center point. Open compass is equal to 30 millimeter. We'll be drawing an arc so that this circular section plane, it is going to intersect with the different generators as well as with the base of this particular hexagonal pyramid. So we observe that after the sectioning of this hexagonal pyramid, so this portion of the base as well as the slant generators will be removed from this hexagonal pyramid over here. So the remaining portion of the hexagonal pyramid, it is represented over here. Now we can see this is the remaining portion of the solid which is left behind. So now we observe that there are 2 points of intersection which will be available onto the base of this hexagonal pyramid. These 2 points of intersection will be lying onto the base over here, onto the XY reference line. So these points, they happen to be point 17 dash and 18 dash over here. So 17 dash point will be lying onto the base edge BC, whereas the 18 point, it will be lying onto the base edge EF over here, right? So this way we have been able to locate these points even in the top view projection. So point 17 happens to lie onto the base edge which lies onto the front side, and point number 18 will be observed or located onto the rear edge of the base EF over here at the midpoint over here. Then the next 2 points of intersection, they happen to be 19 dash and 20 dash. So these 2 points of intersection of the circular cutting plane with the hexagonal pyramid, they are obtained in such a way that this circular cutting plane has intersected with the slant edges O dash C dash and O dash E dash at the points 19 dash and 20 dash respectively. So point number 19, it is available onto the slant edge OC, while point number 20 will be available onto the slant edge OE over here. So wherever the circular cutting plane, it is going to intersect these 2 slant edges O dash C dash and O dash E dash, points 19 dash and 20 dash will be observed, and again both of them, they are going to coincide with each other in the front view projections over here. And finally the last point, it is point 21 dash over here. The intersection of the circular cutting plane with the slant generator O dash D dash provides us with the location of the point 21 dash into the front view projections. Now we observe one thing over here into this construction, that the 2 slant edges OA and OD, they happen to be parallel to the vertical plane. So since the projections of the slant edges in the top view, that is OA and OD, they happen to be parallel to the vertical plane, so on the vertical plane in the front view projections, the projections obtained corresponding to these 2 edges O dash A dash and O dash D dash, they will happen to be true length of the slant edges over here. So we know that all the slant edges, they are going to measure the same length over here. So the true length of the slant edge of the hexagonal pyramid has been obtained as O dash A dash and O dash D dash over here, whereas the remainder 4 slant edges, that is O dash B dash, O dash C dash, O dash E dash, they are represented as apparent lengths obtained into the front view projections over here. So now once we know the true length of the slant edge corresponding to this hexagonal pyramid, so we will be taking this radius OA equal to the true length of the slant edge, which will happen to be equal to O dash A dash and O dash D dash over here. And then with O as the center, OA radius is equal to O dash A dash or O dash D dash. We are going to draw an arc which is going to represent true length of the slant edge over here. So now we know the true length of the edge of the base. True length of the edge of the base happens to be 30 millimeter. So from point A, 6 arcs we are going to mark at a radius of 30 millimeter each, so that we locate the points B, C, D, E, F and A alongside this arc which we had marked corresponding to the true length of the slant edge over here. And now 6 corner points corresponding to the base of the hexagonal pyramid, they have been obtained. Now we can join all these base corners with the apex points, and now once we join all of these edges, so we have been able to obtain the development of lateral surface of this untruncated hexagonal pyramid over here. So now we know that this hexagonal pyramid has been truncated by 2 cutting planes over here. So one cutting plane is auxiliary inclined plane, inclined at an angle of 30 degree. Second cutting plane happens to be a circular sectional plane. So let us obtain all of these points of intersection into the development surface view over here. So the true lengths of these points of intersection from the point O onto the respective slant edges we need to plot now. Now we can observe one thing over here. There are 2 points 11 dash and 14 dash which happen to lie onto the true length of the slant generators. So here once we measure the distance of O dash and 11 dash, so it means that the true length of this point of intersection from the apex, it has been obtained over here, because this slant edge O dash A dash happens to be a true length. So this distance what we have obtained over here, this will be the true length of this point of intersection from the apex point O dash over here. So we'll measure this distance up to 11 dash from O dash, mark it out over here corresponding to the slant edges OA in the beginning and OA at the last section of this particular development over here. Similarly point 14. So point 14 dash, it happens to lie alongside the true length of the slant edge O dash D dash over here. So this distance O dash 14 dash will also be the true length. So we'll measure this distance from O dash to 14 dash. So onto the generator OD, we are going to mark this distance from point O. So distance of point 14 from point O, which is the true length, it has been appropriately marked onto the slant edge OD into the development surface view over here. But there are 4 more points 12, 13, 15 and 16. So these points of intersection, they are obtained onto the apparent length of the slant generator. So now corresponding to these 4 points, we are required to draw horizontal projector lines onto the true lengths over there, either on this side or on this side. So now we can check corresponding to the points 12 and 16. We have drawn a horizontal projector line onto the true length. So corresponding to the slant edges O dash B dash and O dash F dash, we are not going to measure this apparent length distances anymore. That is O dash 12 dash and O dash 16 dash distance will not be measured. Rather, we are going to measure the true length distances while we evaluate the distances of points 12 and 16 onto these slant edges O dash B dash and O dash F dash over here. So this distance O dash 12 1 dash and O dash 16 1 dash distances we are going to measure over here. Similarly, points 13 dash and 15 dash, again they are lying on the apparent lengths corresponding to the slant edges O dash C dash and O dash E dash over here. So once again, from this apparent length radius, we are going to transfer these 2 points onto true length, so that the new true length radius will be O dash 13 1 dash, O dash 15 1 dash corresponding to the intersection points 13 and 15 lying onto the slant edges OC and OE over here. So now we can check. Corresponding to the points 12 and 16, we are not going to measure this distance, that is the apparent length distance from point O dash. Rather, we will be measuring distance of the true length over here from the point O dash. So once we measure this distance O dash, 12-1 dash or O dash 16-1 dash, so onto the slant edge OB, this distance will be plotted. We will be evaluating point 12-1 over here. Onto the slant edge OF, same distance will be plotted over here. So we'll be able to obtain the point 16-1 over here. So the next 2 points, they happen to be points 13 and 15. So once again, this apparent length distance we are not going to mark onto OC and OE. So rather, we are going to measure the distance from O dash to 13-1 dash and 15-1 dash over here. So this distance, once we mark onto the slant edge OC, we obtain the point 13-1. Once we mark this distance onto the slant edge OE, so we will be able to obtain the point 15-1 over here. So all the points of intersection of the AIP with the top surface of this hexagonal pyramid, they have been obtained over here. Now let us obtain these 5 points of intersection of this circular sectional plane into the development surface area over here. So we know that the circular cutting plane, it has intersected with the base of this hexagonal pyramid at 2 points, 17 dash and 18 dash. 17 dash point and 18 dash point, if we project it into the top view projections, so now we have evaluated that point 17 happens to lie onto the base edge, which is lying onto the front side at the midpoint. So 17 point, it is the midpoint of BC. Similarly, point 18, it happens to lie onto the rear edge of the base EF over here. So onto edge BC, we have marked the midpoint. So point 17 has been located. Onto edge EF, we have marked this point 18 as a midpoint. So point 18 has been located over here. And once again, the points 19 dash and 20 dash over here, they are lying onto the slant generators apparent lengths O dash C dash and O dash E dash over here. So this radius O dash 19 dash and O dash 20 dash will be the apparent length of the radius. So let us now transfer this radius onto the true length. So at this point of intersection, we are going to obtain this radius distance is equal to O dash 19 1 dash and O dash 21 dash over here. So onto the 2 generators OC and OE, if we mark these 2 distances, points 19 1 onto the generator OC and point 21 onto the slant generator OE, we have evaluated over here. And finally, point number 21 dash, it happens to lie onto the true length of the slant generator O dash D dash. So it is a true length itself, O dash D dash. So this radius O dash 21 dash over here. So this will be the true length of the radius of point of intersection number 21 over here. So if we measure this distance O dash 21 dash over here, mark this distance onto the slant generator, onto the slant edge OD over here, point number 21 has been obtained appropriately into the development surface area over here. Now let us join the different points. So onto the top face, and AIP has cut this solid at different points. So the straight line projections, they have to be joined over here. We have to join different points of the top face using straight lines. Whereas over here, there is a circular sectional plane which is cutting this hexagonal pyramid. So these points at the base, they will be joined in the form of a curve over here. So here we are going to join all these points as a curve. Now we can check this portion of the hexagonal base. It has not been intersected by the cutting plane. So this portion is AB and FA over here. Similarly, the portion of BC, this portion has not been cut. Similarly, the portion of EF, this portion has also not been cut. So half of BC has not been cut, half of EF has not been cut, AF and AB, they have also not been cut over here. So this way we can join the remainder portion of the solid over here and the development points we have been able to obtain. And then the slant edges of the truncated solid now we can join over here. So this way we have been able to obtain the sectional front view, the top view projections and the development of the lateral surface of the truncated hexagonal pyramid, which has been cut by two cutting planes. The first cutting plane happens to be an auxiliary inclined plane, inclined at an angle of 30 degrees to the horizontal plane, passing through the axis at a point 30 millimeter below the apex point. Whereas the second cutting plane, it originates from the right hand side corner of the base and it is a circular sectional plane which is having radius is equal to 30 millimeter and it passes through the base as well as the three slant edges of this particular hexagonal pyramid. So this is all for today. So I hope that through this discussion you would have understood about the procedure to obtain the front view projections, the top view projections and the development of the lateral surface of the hexagonal pyramid which has been cut by multiple sectional planes in the different orientations. So we will be continuing with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures over here. So thank you very much. Thanks a lot.